All right, this is Chapter 10, Section 5, Hyperbolas. Our objective is to graph the hyperbola and to find and use the foci of a hyperbola. So there's two different equations for hyperbola. What I want you to note is that the difference between a hyperbola and ellipse is this minus sign right here. The graph of a hyperbola are two opposite parabolas. So if you're horizontal, then you open up onto the x-axis. If you're vertical, then you open up with the y-axis centering you. The only difference between the horizontal and the vertical as far as the equation goes is that when you're vertical, the y squared comes first, and when you're horizontal, the x squared comes first. All right. So we're going to use that information, those equations, to find the standard form of a hyperbola with a vertice at 0, -4, and a foci at 0, plus or minus 5. Sketch the hyperbola, and in fact, that's what I usually do first, is I will sketch, because it helps organize my brain if I can see a picture. So the vertice is at 0, -4, and 0, 4. Are these two right here. And the foci are at 0, plus or minus 5. Just right here, right here. So we're going to open around the foci, because remember we would like to hug our foci. So this is a vertical hyperbola. So we're going to be using this equation. So we've got y squared over a squared minus x squared over b squared equals 1. Okay, we need to identify, we can easily identify our A value. It's the distance. It's either half the distance from vertex to vertex. So that distance here is 8. So half of that distance is 4. So our A value is 4. And a squared would be 16. We need to find our b squared value, and we're going to do that by working our way, using the focus, and working our way backwards. So if we look here, our focus C squared is equal to a squared plus b squared. So let's backtrack. So if we know that C is 5, we can go 5 squared is equal to a squared plus b squared. So we know that b squared is equal to 9. So that's the standard form of the hyperbola. And then one thing I like to do is I like to make the AB box. So if I know that B is equal to 3, so here, 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 and here, I'm going to make a box to make my asymptotes easy to draw. So based on A and B, I make a box and I know my asymptotes are going to go through my hyperbola center and each corner of this asymptote box. So it's a quick and easy way to make the asymptotes. And once I do, my hyperbola opens towards its foci and then grows towards the asymptotes. All right, so that's a scenario where we're given information and we need to graph it. In this example question, we have the equation and we need to find the foci and graph the hyperbola. So to find the foci, we see that this is because x is first in this equation, we see that we are a horizontal hyperbola. So we're going to use this information, and we know that the focus is at plus or minus c comma 0. So we're going to find A. If a squared is equal to 36, then a is equal to 6. If b squared is equal to 225, then b is equal to 15. I'm going to use the focus formula to find out what my focus is. A squared is 36, b squared is 225. The two of them together, 36 plus 225. 11, carry the 1. C squared is 261. And now I'm doubting my math, so I'm double checking. 36 plus 225. 261. Okay. And the square root is 16.15, so I'm just going to keep 261. So C is equal to the square root of 261. So my foci is at plus or minus root 261, comma 0. And now let's graph it. So if we have So I'm looking, my A is on the x-axis and my B is on the y, so I'm going to need 15 here. No. I know it's fascinating to watch me graph. Okay, so let's put our vertices on here. I know that I have a vertice at a comma 0, so that's 6 comma 0. And I have a vertice at negative 6 comma 0. And I have, so we're going to open up at root 261, which is about 16. So my foci is here. So we're going to open up around it. And then I need to draw my AB box. So if A is here, we're going to draw our box out here, and then B is 15. So I draw my AB box. so that I can draw my asymptotes. So my asymptote is going to go through the corner, the center, and the corner. I click send page. So here's my first asymptote and my second asymptote. It's going to do the same thing. So my graph is going to be really wide. He's a fat guy. And really wide. Let's use Desmos to check our graph. So x squared over 36 minus y squared over 225. And in the time it's taken to load, I have forgotten what the equation is. Minus y squared. We look, we are going in the right direction. It's super wide. Awesome. Phew, got that right. Okay, and that's hyperbolas for you.